Hi guys, my name is Ben. Welcome to my double linked list part 1. If you guys recall on my previous video, you can see that we did single linked lists and we're able to allocate memory and write data to those memory we allocated and use an iteration to print those data. But there was a limitation in single linked list. The limitation was that we're able to print that data in a parallel way, in a parallel form, which means we're able to move forward, but the ability to move backward was not given to us. Alright, so when moving backward using the single linked list is something very difficult to do, except you want to jump back to the beginning of the node and start printing from that node, and which is not worth the time. Okay, so this is where double linked list comes in. In double linked list, we can print from the back and also from the front, which means we can move forward and also backward, and that is the beauty of double linked list, okay, compared to single linked list. I like practical more of theory, so let's jump straight into practical. All right guys, so we're going to create a directory here. We're going to call it double underscore link underscore list. Okay, so this is just a directory, an empty directory. So we move into that directory by typing cd double link underscore list. So we are in that directory now. If I type pwd, which stands for print working directory, it tells us the paths that we are in the system. All right, so we have no file here. If I do ls, it's an empty clean directory. Okay, so we're going to create a file. So I'm going to call this file, okay, I'm going to call it double, all right, link, okay, list. I prefer naming it this way. The double was not spelled well though. Double link list. Okay, each of the characters start with the uppercase, so which allows to know that this means double link list. Okay, I will just put 1 to make it to just kind of like part 1 of double linked list video series. So I will do .c to give it an extension that will tell the CPU to execute this program as a C binary. All right, we'll press enter. So that creates a file called double linked list 1.c. ls, you can now see this directory contains a single file. So it's time to write our program. Okay, we'll use the Vim editor that we have been using right from the start, where we did the single linked list. Okay, so I will say double linked list .c and press enter. Here we can now start writing our program. I for insertion, then I have to include all necessary header files that I need for this program to work accurately. So I will include the stdio.h that gives me access to functions like file printf and printf and the rest of it as well, but for now we'll just use this to make things simple. So I will also include another standard library header file called lib.h that gives us access to stuff like malloc and stuff like the exit function. All right, yeah, we need to add one more, I think so. Yeah, I think we should add the error number just for error checking. All right, this error number has an dynamic, which is an instant variable, okay, that holds the return value that indicates the error that a particular function throwbacks to us. So that instant variable is called errn0. Is an instant. Okay, most we do call it instant micro most times. All right, so yeah, we also need to include one more before I forget, which is known as the string.h, because it kind of like you need a description about this error. So the function we're going to be using inside this string.h is called strerror, okay, which is a string that allows to give us that print the description of an error number. Okay, so that is it. So the next thing we're going to do now is to write our double linked list. Okay, so to write double linked list, it's just the same way we write the single linked list. It's just that a single self-referential node is being added. So we do struct node. I like using node because it's a very nice identifier to represent a double linked list or a single linked list or even a circular linked list. Do the open curly brace, press enter. The member of this node structure will be int first, where the data is going to be stored. Then we're going to write the self-referential here called node asterisk. Then I'm going to call this forward. Okay, then we're going to add another one. Okay, node asterisk. I'm going to call this one backward, and close that and put semicolon. So that is it. So the next thing is main. Okay, in the main I'm going to pass in void, because when you pass in an argument into main such as like this, okay, and you did not make use of it, it makes your program vulnerable. So an attacker can create a kind of like exploit, and once that happens, he have access into your memory, into your computer entirely. Alright, so we just remove that and pass void, since we are not receiving any argument from the command line. Alright, so what I did up here is how double linked list is created. So I'll just give a quick comment there. Double linked list. Okay, so this is how we write it in C language. Alright, so we come back to this main. So what is the work of main? The work of main is to tell the CPU where to start executing our program. This is same in C++, okay. Alright, so the next thing is for us to start writing our code. So I'm going to make this program simple. Double linked list is not as easy as single linked list, but I'm going to explain it, and I'll make sure that I explain it in a way that you understand. So what we're going to do here is for us to create maybe more than one memory allocation, or any amount we want, depending on how we want to exercise or how I want to explain how double linked list is or is all about. Okay, so what I'm going to do first is I'm going to create a struct here, so which is of node, which will be a pointer. So I'm going to call this something like first. I'm going to say first node. Alright, I'll say equals to, I'll say equals to null for now. Alright, whenever you create a struct and you're making use of it, make sure you assign it in null. That null means 0, so I will just comment that place. I'll say null here means 0. Sorry, null means 0. Yeah, that is 0. I'm still making mistake putting 8. That's my typing, sorry. So null here means 0. The 0 also we are trying to say is the same 0. Okay, yeah. So after that, we're also going to create another, let's create a tree struct of node. So one we call first node, the other one we call second node, and the other one we call third node. So I will say the same struct node pointer. So I'm going to call this one second node. Alright, there are ways to name an identifier, which is most times the best way. So instead of putting it like this, I'll put uppercase F, and in the node here I'll put uppercase N. Most people name this way. Yeah, I think it's nice. Why most people name this way? They'll just make everything small letter and use underscore to separate them. Anyone you do is nice. They are all nice. Okay. Alright, for the sake of simplicity, maybe let's leave it like this, underscore. Alright, so underscore node. Alright, which is second node. I will say this should be also equals to null. Alright, so remember null means 0, so there's no need of me commenting that code. So I'll just create 3 though. I think it would be nice if I create 3. So I will say third underscore node, we'll say equals to, alright, null also, and that is it. Okay, let's make it 4. Why not? Struct, or even 5. Why not, guys? So fourth, think spell fourth underscore node, we say equals to null. Alright, yeah. So let's make it the 5th one. Struct underscore node asterisk, we say fifth underscore node equals to null. Alright, so we just create 5 node here. Alright, fourth, first, this is first, second, third, fourth, and fifth. So what we're going to do to this now is to allocate a memory space for each of these. Alright, there are ways we can do this, okay, which is the best is that we are going to create a function that will allow us to create a node instead of us at every given time writing node at every given place. But for the sake of simplicity, I'm not going to do that. Maybe in the part 2 of double linked list, but for now we're just going to write everything manually so you guys understand what we are doing or what I'm doing. So I'm going to say here first the first node. I'm going to say first right underscore node, we say equals to. Now when we use malloc allows us to return a typecast, to do typecasting. So that typecasting tells us that what kind of value do you want malloc to return. So here we want to do a cast of struct node because that's what we want, and it will be a pointer, right? So node, it will be a pointer of node. So this is what we want malloc to return. Then we have to just call malloc, and malloc accept one argument, which is the size of the memory you are allocating. So the size here should be of the struct node. Alright, here we don't need to put pointer in it, put semicolon, then we'll press enter. Then it's always good to check for errors. Alright, so we say if first underscore node, okay, happen to be equals to null, and it will never be equals to none because this code actually assign an address to first node. So this error here will be skipped, but if per adventure there was an error, so we would like to see the error by using fprintf function. Okay, we say we want to send the error to the standard error command, and we like to get a description of that error, the error number and the error description. So we'll do error number, okay, I will do colon %d. I'll just keep a simple arrow sign and %s to give us the description. Just pass a new line here, and that's all. So error number will be passed to the %d, comma, and we'll use the string error, okay, and pass the error number to give us the description of the error number, and that's all. So once we're done, we press enter. Alright, so this will give us the error of what happens in the program. So since we get an error, we would like to exit this program by doing this. So what are we exiting? We are sending a signal that something happened, so the program failed, and because the program failed, we would like to quit, and we quit that, and that is it. Most people will use return. It's not always good to use return to a function most times makes your program vulnerable. Hackers can also use it, so you better use the function exit, or you can use the system call exit. Alright, so this we just did here is all we need to do at every given node. So for me not to start writing all these things again, I will just copy them. Like I will count it from the first, which is 1 2 3 4 5. Alright, so I will copy this 5 code. Alright, so I will just come up here. It must be at the top here where you want to start copying. So since it's 5 lines I want to copy, I will just press escape key and press 5 and press Y double times, Y, and it yanks 5 lines. You can see it at the bottom there. Okay, then I will now come at the bottom here and now press P once to paste that. Okay, so I'll press I to now edit it. So instead of first node, this will become second node. Alright, so this error, instead of first here, it will now become second. Right, so once I'm done with this, I will also come here, press I for insertion. I also come here, press enter. This is an error though, so we didn't write this properly. It should be called return, URE, where return, no, return, yeah. So at the bottom here, I'll press enter. So here, remember what we yanked is copied, and VMC keep hold of what you have yanked, which means if I press escape and press P again, Vim automatically detect that in its database and paste that which we have yanked before, which is what we have copied. So if I press P, you see it still copy that, see paste that pipeline of code. So this time around I will now say here it should be now here will now be third. Alright, so I'll take all this and I'll type TIRD, sorry, RD. Then I'll come down here as well. Instead of first, I will now change this to TIRD, and that is it. So I'll do the same, come down again, I'll press escape and I'll press another P. It pastes that again, I for insertion key, remove the first again, and this will become FORTH, which is fourth, and here also become FORTH, which is fourth node. Now go down again. Okay, so I'll also press escape and press P. So this will now become the fifth one. I for insertion, and this will be called FIFTH, fifth, right? So we come here also FIFTH, fifth node, and that is it. So we are done with all this. Okay, now that we have allocated memory for each of the node, okay, you can see everything I did, very pretty simple. Or you can pause the video and also look at each of them one after another. First node allocated heap memory. This error will be skipped because I believe my code is correct. The second one, we allocate another heap memory. This error in this if here will be skipped because the code is correct. The third one here also, we allocate another memory. This error here will be skipped because the code is correct. The fourth one same, the fifth one same. Okay, now that we have successfully allocated memory for them, so which means in the RAM, which is the CPU, this memory has been set, but there is no data in them and they are not linked front and back. Okay, so how do we now issue data to them and link them together to move to and fro like front and back? So what we're gonna do here now is that we're gonna say the first node, okay, underscore node, okay, points to its data. So we say the data this time should be equals to 100 semicolon. So we'll now say this first node, okay, underscore node also have another members which is known as forward. Now this forward now will be equals to the second node, okay, underscore node semicolon. And remember this same first node, okay, has a backward. Okay, so we say backward. Since there is no place to point to which is the backward, we now say backward here should be equals to what? Null. Alright, so once we are done with that, we move down. We say second node this time around, which is also a node in the memory. So we say point to its data. So its data should be equals to 200 semicolon. So we say this second node now also have a forward. Remember that. Okay, we say its forward, right? The forward is not well spelled. Say forward, right? Yeah, is equals, should be equals to third underscore node, right? And now why this second also have a member of backward, okay, back node, okay, backward. So now this backward will now point to the first node. Say backward should now be equals to first underscore node. Do you see that? So this line here take us forward, this line here from here take us forward. This one has no backward, so it should be equals to null. So this one take us to forward, which is the third, while this one take us to back to the first node. Now the third node, you say third right underscore node. We say this is also has a data a member, so the data this time around should be 300, and we say third node also have a member of forward. Alright, so we say forward should be equals to fourth underscore node, and this third node also have that was a mistake, there should be arrow here, also have a backward which should be equals to, this time around, the third node. Is that understood? Alright, so now we also have a fourth node, right? The fourth node pointing has a member called data. We say this data should be equals to 400, and this same fourth node okay has a member called forward, right? And this forward now should be equals to 50, right? Underscore node, semicolon. And this same fourth node okay point has a member called backward, and that backward should be now be equals to what? Third node should now be equals to third node. Okay, so this one we are doing mistake here. Instead of, we are supposed to put second node here, we can put third. All right, second node, and this will now be third node. And now we are now heading over to the final node, which is fifth node. So this fifth node also has a member of data, so this time around we give the data 500, and this same fifth underscore node okay has a member of forward. Okay, now this forward, since we have no node now, this forward will now be equals to what? Null. Alright, and this fifth node okay has a member, this fifth node okay, remember it has a member of backward, so this backward will now be equals to what? Fourth underscore node. Is that understood? You see how it's been arranged? Okay, oh, there is an error here. I'm supposed to put equal sign here. Okay, so the code is well arranged now, so we have successfully connected the node to front and back. Okay, so the first node have 100, first node pointing to forward will point to second node, while the backward of the first node points to nowhere. While the second node have a data of 200, the forward point to third node, while the backward point to fourth node. Now the third node has a data of 300, and the third node forward points to fourth node, and the backward points to second node. Now the fourth node has a data of 400, its forward points to fifth node, and the backward points to third node. Now the last node have a data of 500, the forward points to nowhere, while the third points to, the backward points to fourth node. So that is it. So with this now we can print forward and backward. So what I will just do here, guys, is I will write a function with printf, and I will say print, I will just say printing, printing forward. So we are printing forward, okay, forward node. All right, I'll put double \n here, then we close this. Then here I'm gonna say struct, okay, I'm gonna say struct, because I would like to create a temporary structure, guys. Oh, sorry for this, guys. I will create a temporary structure. I will call this node asterisk, and I'll call this tmp temporary. I'll call this temporary 1. Okay, I'll say it's equals to head. Alright, semicolon. I'll press enter. Then I will use the while statement, and I will say this temp1, once it's not equals to null, Alright, so this is what we want to print. So we want to use the printf function to say we are printing data. We say forward data, forward data, then here we'll column %d, say %d, okay, /n, double quote, put my comma, and here I will now say temp1 pointing to data, and that is it. So when I press enter, so what we move to the next node will be the temp1 equals to temp1 pointing to forward, and that is how we move, and we close the curly brace. This same code will be applied for backward. So I will just print 1. I will copy this line 1 2 3 4 5 6. So I'll come at the top here and I'll press escape and I'll press 6 and press Y 2 times to yank. Then I will now come at the bottom here, okay, press I first and press enter first to give space. Then I'll come at the bottom here, escape, and I'll now press P to now paste that line. So instead of writing here forward, I for insertion, I will write here in uppercase backward, okay, backward node. Then I'll come here, instead of temp1 I'll call this temp2. Alright, so instead of head I'll call this 5th node. Oh sorry, there was no head here, so 5th node. So instead of head, sorry, there was no head here, we didn't use head. You know, we C programmers normally use head as the first node, so that's why I made a mistake there. So this will be first underscore node, yeah. So and this should be 5th node. So we'll now come here, my error shaking will now change from 1 from here to become 2, and the print here will also change from 1 here to become 2, and here will also change from here to become 2, and the other will also become 2. Okay, so this is a simple function that prints those nodes. So at the end of it here, I would just like to give /n to just give a little bit space. Alright, so guys, let's go run this program. You can pause the program and watch how everything is. Just about 87 lines of code, that's not much. You can see, you can pause as I scroll up, and you know, make sure you write all these things. Very simple. I did my best to explain everything here. Alright, so let's go compile this program. So if there's any mistake, we'll come and fix. So escape shift : WQ, press enter, clear my screen. ls, you see ls, you see our source code, so it's time to compile. So we gcc, okay, double linked list -0 -o, which stands for output the object. Okay, there are procedure when compilation is going on, but that I will explain in another video. So we do double linked list, then we have to remove the .c. So if there is no error, our program should compile successfully. But if there is error, we will see the error and follow the error, trace back to the error and fix it. So press enter. So we have some error, yeah, so some just minor errors we just have to fix. Okay, so let's go and fix that. There are just 2 errors. One is on line 18, the other is on line 45. Okay, so vim double.c, press enter, line 18. So we go to line 18. Okay, so this is line 18. So where are we making mistake? We say, oh yes, should be equal sign. Yeah, you can see that was just a minor mistake. So the other one is line 45. So where is line 45? Is here. Okay, malloc. Okay, 5th. Okay, where we use the 5th node, yeah, because we're making mistake, that's why it's giving us. So there's no error here actually. It's because of the error line 18. That's why this place was giving us error. Alright, so we escape, we save, and we press Ctrl P several times, and it gives us our previous typed characters. So press enter and the program compiles. So ls, we have our executable binary. Clear the screen again, /, double. Now if I press enter, the program should run without no segmentation faults. Now you see, and this is the program. So we have printing forward, we have 100, 200, 200, 400, 500. When we have printing backward, we have only 500. So the error was from my own end, so I will just go fix that. So I will do I also have to go back to the code. Sorry guys, that was from me. Alright, I didn't put the backward there, that's why. So we just come down here to the bottom here. Remember, went and put forward. We should have we copy this line of code, so there is forward here for the forward node. So this should be backward. Yeah, this should be backward. I for insertion key, so I'm supposed to put backward here. Alright, another mistake I'm making here is, which is a very good practice, is to free all those nodes. Alright, so we are supposed to say we free first. We are supposed to say we free first underscore node. Okay, semicolon. We're also supposed to free second underscore node. Okay, we're also supposed to free third underscore node, and we're also supposed to free fourth underscore node, and we're also supposed to free fifth underscore node. Alright, so this is just it. First free. When you free this thing, what it means is that giving back the borrowed space to the system back. So let me give a comment. This means it means give back borrowed memory space to this system. Okay, that's what it just means. So we are giving what we borrowed. Malloc allows us to borrow, while free allows us to give back. So give back borrowed memory space to the system, and that's all. So let's go compile now, and our program will work very well. Okay, so we now use that Ctrl P to bring format GCC double linked list minus o double linked list 1. So press enter, that compiles. Okay, you see a little bit mistake there. So I just normally make mistake while typing. I'm sorry guys. So we just go to that bottom, that last code we just added. So you see there's a place we added semicolon, colon, why we are supposed to include semicolon. So we're supposed to put semicolon. So that's the only error. So we clear the screen and recompile now. So it compiles ls. We have a stable code // double. Now if I press enter, now you can see forward. If I move up, you will see printing forward data 100, forward data 200, 300, 400, 500. Now printing data backward, you can see forward data 500, forward data 400, forward data 300, 400, 200, and forward data 100. You see how we're able to print all these programs? Isn't that nice, guys? So if you like what I just did, and make sure you subscribe to my YouTube channel, and if you are watching from the TikTok, please share this video to your loved ones, and I'll be going live very soon, probably maybe on Thursday or tomorrow. I'll be going live, so stick around, okay, and have a nice day. Bye bye. So see you guys.